Here I create two virtual machines and two folders to save them. One is the target machine and the other one is the host machine. And it's also the debugger machine. Here we have already opened the two virtual machines and we are testing the serial port is connect or not. Here we use the command cat def ttys1 and echo the test for ttys1 and my student numbers in the target machine, and it will show up in the host machine, and it confirms that the serial port has connected correctly. Here we can see that the .config file has already exists in the path usr src linux-4.19.150, and it means that we have already downloaded the Linux kernel we need. Here we want to make sure that our configuration of the kernel is correct. Like here we use the command sudo make manual config to check that the 64-bit kernel is select and the virtualization is select. And we go to the file in the usr src linux-4.19.150 and we check that the option config frame pointer has set to value 1. It allows debugger construct stack traces more accurately. And we check that like the config kgdb or the option config kgdb serial console config kgdb kdb and so on are all set to the value 1. It allows us to compile the kernel with KDB. Here we want to build our Linux kernel. We first using the command sudo make-j nproc to compile and create a compressed kernel image. Second, we use the command sudo make modules install, and by using this we install the kernel modules. And after we compile the kernel and install the kernel modules, we using this command sudo make install to install the kernel itself. And after we run all these three commands, we have built our Linux kernel. Here we want to update our CR of the graph. First, using the command sudo update dash inner channels to update inner channels to work with a new kernel. And after that, update the graph. Second, since the default of graph will not display, we go to the graph file in the etc default and change the line graph data timeout equals 0 and align graph data timeout class equal to into an annotation. By doing this, we can force graph to be displayed. And after that, we save this file and update the graph again. Third, we use nano command to modify the file graph.cfg at the path boot graph and add kgdb weight and kgdboc equals ttys1 e115200 at this line. By doing this, we can make kgdb wait for debugger connection to inputting of a kernel. Finally, we go to the host machine and copy the VM Linux we created in target machine to the kgdb image folder which we create in the host machine. By doing this, it makes sure that we can debug the target machine with host machine correctly. Now we want to perform the debugger process. First, we change path to the path that our VNiners are, and we load in VNiners with GDB. And after loading, we connect to the target machine by using this command target remote dash dev dash ttys1. As you can see, at this point the target machine is still be frozen because we have a ladder kernel execution. And after we key in the command continue, and we let GDB continue to execute, then the target machine will finally boot up successfully. And this is the whole project 1A. Thank you.